Hello, my name is Promise Swedi, and I'm delighted to present my dissertation project on loan default prediction using machine learning. So this research was carried out as a part of my MSc at the British College, affiliated to the Leeds Beckett University under the supervision of Dr. Roshan Kuzu. So, moving towards the overview, so loan defaults are it's just a growing challenge of the financial institutions. Microfinance organization and peer-to-peer lending platforms. So when the borrowers fail to repay, it's not only reduce the profitability of, but also threatens the overall financial stability of the lenders. So traditionally, banks have relied on models like the logistic regressions, which are transparent and easy to interpret. However, they often oversimplify the problems and fail to capture the complexity of borrowers' behaviors. So, with the rise of the fintech and the availability of the larger data sets, machine learning models have emerged as strong alternatives. And my research explores these models and shows how they can be made more practical, interpretable, and the cost aware for the real world use. So, looking at the research gap and aims and objectives. So, from the literatures review that I have done, so I have majorly identified four keys gaps that shaped up my study. So, the first one is must the previous research evaluates the models mainly using accuracy and ROCAUC or FN scores, but very few evaluate calibrations, which is crucial for credit risks. And calibration means like checking whether the predicted probabilities of default actually it matches the observation default rates or not. Like for example, if a model says 100 borrowers have a 70% chance of default, then ideally about 70 of them should default, and many should studies ignores this, which reduce the real world trust as well. So second, there is a little considerations of cost asymmetry in lending. Missing a defaulters, a false negative is far more damaging than mistakenly flagging a safe borrower here. So most studies still use a fixed threshold of zero point 0.5, which does not reflect the real economic of this lending decisions. So the third one here, it's a feature engineering is underutilized. So many works use raw lending data set, but financial ratios such as loan to income, installment to income, and credit utilizations are direct measures of affordability and repayment capacity. So when engineered, these features often outperforms the RAWS one. So looking at the fourth, its interpretability is lacking, and they often are treated as a black box. So few studies compare feature importance across multiple model families to explain why the predictions are made. So my research focuses on filling these gaps like calibration, cost aware, thresholds, or domain driven features engineering, and interpretability. So looking at the aims and objectives, the aim of my study actually it is to evaluate and compare the machine learning models for a loan default predictions and it's emphasizing on the calibration, cost sensitivity, and interpretability. And to achieve this, I have said the following like objectives like cleaning and pre-processing the data sets, handling the duplicates, missing values, and the leakage, and to engineer the domain specific financial features such as affordability or ratios, and even training the five model logistic regressions, random forest, XGBoost, light GVM, and CatBoost. And it also evaluates them not only with the discriminations matrix like ROC, AUC, and PR AUC, but also but also calibration metrics like log ROS and like Bright score to apply the probability calibrations methods such as isotonic regressions. And it also interpret the models by comparing the features importance and across the families. If looking at the methodology, so there is a clear pipeline which you can see here on the posters flow chart. So I begin with the data preparations, which includes like removing the duplicates, cleaning missing values, and dropping the leakage fields such as loan IDs and repayment dates, and splitting the data into the stratified train, validations, and the test sets. So next is the feature engineering here. And I created meaningful features including the monthly installments to income ratios, loan to income ratios, and credit utilization. So this actually reflects the affordability and were found to be highly predictive as well. So for encoding and scaling, I applied the ordinal encoding for the ordered categories like education, and one hot encoding for the nominal variables like employment type and marital status, and standard scaling for the logistic regressions. And I then moved to the model training, where I tested five different algorithms or logistic regressions as a baseline, and a random forest has a traditional ensembles, and three boosting algorithms like cat boost, like gbm, xgboost, and others. And evaluation metrics included the roc auc and prauc for the discriminations, log loss, and Brier score for the calibration, and visual inspections through roc and pr curves. So I also applied the threshold tuning. So instead of the default zero point 0.5 cutoff, so I optimized the threshold to reflect the higher penalties for the false negatives. In practice, this means setting the thresholds around 0.82, sorry, 0.62. So finally, I analyzed of the feature importance across all the models to identify the most influential predictors here. So if looking at to the research outcomes and decisions, so uh, what we have what I have gained actually is the logical regressions. So when calibrated, provided the most reliable probability here, achieving the lowest log loss and Brier score. This shows that even a simple model can be useful if properly it's calibrated. So cat boost achieved the highest PRAUC here. If you see, you can see it over here, making it the most effective at identifying the actual defaulters here. And XG boost performs strongly in ranking borrowers, but needed calibration to improve the probability trustworthiness here. And if you look at light BGM, light GBM, it shows the decent calibration but weakest at PRAUC here. And if you look at the random forest, it underperformed compared to the boosting methods. In terms of the feature importance across all the models, the most predictive features were the loan to income, installment to income, age credit scores, and the interest rate. These results, it highlights the value of engineered affordability ratios in credit risk modeling actually. So moving towards the conclusion here, this story basically showed that the cat boost and the xg boost are the most effective when the goal is to rank the risky borrowers, while logistic regressions with the calibration remains the most reliable for the producing the trustworthy probability of the default estimates. So by addressing the calibrations, the cost sensitive thresholds and interpretability of this research makes machine learning models more suitable for the real world learning here. And for the future work, what I recommend here is the fairness testing across the demographic groups, temporal validations across the different years, and exploring the advanced calibration methods such as Bayesian approaches would be better. So looking at the ethical considerations, so this research used only secondary anonymized data sets from the public sources such as Kaggle. So I have used Kaggle here, the dataset from the Kaggle. So no primary data collections or user participation was involved, and all the data was used solely for the academic purposes. And the ethical guidelines of the university was also strictly followed here. So that I have already said over here. So the other here is the references that I have taken, and the literature reviews are over here. So moving towards the prototype. To put these all things in the practice, so I have designed a prototype powered by a cat boost. So I want to demonstrate that here. Mm. So this is my interface of my prototype. So on the left we can see the settings panel where the decision threshold is displayed, and it is set at 0.62. So this threshold is it balances the trade-off between the catching defaulters and avoiding the false alarms. So on the right side, there is form for entering the borrower's details, such as like you can see over here, age, annual incomes, and loan amount, credit scores. So and other financials and the demographic attributes over here, like education, employment type, marital status, and so this is the single prediction actually. So if we like, we can make changes over here, like let's walk through this example borrower. So so suppose like the applicant is the age is 21 years old. I just keep here 21. Like it has the annual income of like 50,000, uh, annual income of 50,000, and let's keep the credit score, as 300, as it's list credit scores, list of others. Okay, let's look at the DTI ratio. So I'll be keeping it 0.95. So education, high school, employment type I keep salary, marital status, okay, let's change it to the married, and they have dependents, it has mortgage as well, and has a coin. So if I predict this, so the prediction is 0.60, 0.604. 0.604, that means like if you look over here, so I have kept the resistance threshold at 0.62. So if it is above like 0.604, if it's above 0.62, then it's taken as the default lenders has, so it's default loan here. So we also have the other the batch CSV section over here, where we can upload the CSV file, and it can predict like it supports the batch prediction actually. So and where the lenders, they can upload a CSV and with multiple application and gets the prediction for an entire portfolio here. So if I browse files over here, and then I'll select this. mm, so here you can see the file has been uploaded. It's the first rows, and the prediction is also ready over here. So this prediction, we can download the predictions CSBO from here. So to summarize, so this project was that the machine learning, especially the cat boost, can significantly improve the loan default predictions, and by combining the engineered features, calibrations, and cost sensitive thresholds and interpretability, the results becomes not only accurate but also it's practical for the lenders. The prototype, it also demonstrates how these models can be applied in real decision making, both for the single applicants and for the batch processings. So that's all. Thank you for watching my presentations. Thank you so much.